Hello Math 152 students. In this video, we want to take a look at wrapping up this example and finishing 8.1. So in the last video, we looked at calculating the shape, mean, and standard deviation for a sample of size 25. And I want to point out that in this next part, we're calculating a probability for a sample mean for a sample of size 25. It's important that you pay attention to your sample size. A lot of times they will ask you to do this in sequence, kind of like we're doing, where you're computing shape, mean, and standard deviation, and then use those numbers to answer probability questions. But then sometimes in later parts, they might change this to a size of 35 or 45. And if you have a different sample size, your standard deviation is going to change. So this standard deviation of 0.64 only applies to the distribution, the sample mean, for a sample of size 25. If we change to 35 or 45, this standard deviation would change. The mean would actually stay the same because the underlying distribution still has a mean of 11.4, and the mean formula doesn't have the n in it. So let's go ahead and go to StackCrunch. StackCrunch needs to know our mean and our standard deviation. And what we had pulled up before, we were actually looking at the underlying distribution. Just another place you'll want to be careful. Here, since we just did an individual less than 10 minutes, we probably aren't going to repeat this as our answer. But sometimes as you're working these problems, it's easy to forget that. What we actually want to input is our new standard deviation for size 25. So notice I'm still shading below 10, but this is a much smaller area, approximately 1.4%. We could say 1%. And what I want to illustrate is going on may be easier to see if we click the marks for our 1, 2, and 3 standard deviation tick marks. Notice with a small standard deviation, this curve is much more tightly centered around the mean. The top part of your curve is only about 13.3. only about 9.5, 3 standard deviations below. But in my underlying population, if I change this back to my population standard deviation, and then I click my tick marks, 3 standard deviations above average is already at 21. 3 standard deviations below, under 2 minutes. So what's really driving this is the fact that a smaller standard deviation has huge implications for your probabilities. 10 minutes is quite a bit below the mean when your standard deviation is small. So what is this telling us? Well, for an individual, less than 10 minutes was about 33%. But for a group of 25, the chances that their average for all 25 is under 10 minutes is pretty small. Right? If it's not all that likely that one person is going to be under 10 minutes, it's probably not going to be very likely that your average is going to be under 10 minutes. So again, in this case, there's a lot of reading comprehension in Chapter 8 and making sure that you're careful about, is it an underlying population? Do I have an n value? Am I changing that n value? And just being very careful with what's going on. Let's go back to our slide, kind of summarize this example, and we'll take a look at our ebook. So before we go on to our next slide, let's tackle the is it unusual question. For is it unusual, your book is going to use 5% as the benchmark for unusual for most of the time. Now, it's not always 5%. In some contexts, it could be 1% or 10% or a number that makes sense in the context. But 5% is our sort of standard benchmark for unusual unless it's specified otherwise. So with a percent, 1.4%, I would say yes, this is an unusual thing to see. If I took a sample of 25 and the mean time is less than 10 minutes, I might say, wow, they were really doing good today. They're on top of it and they're getting those cars in and out. So we want to think about sometimes if something is unusual but you're observing it, what does that mean later? What is it telling you about that sample? Is something going on that's changed? Or maybe we might want to examine our data and ask some other questions. So one last slide for summary here, just to kind of summarize what's going on. I want to make sure you see the difference. The first question was asking about one specific oil change, like you as an individual, being under 10 minutes. And the second question is the average oil change for a group being under 10 minutes. So that's the contrast we're going to see between Chapter 7 and 8. Chapter 7 had to do with an individual. Chapter 8 is having to do with a group and a specified end value. So the last thing I want to do is point you in the direction of your ebook just to give us a chance to see some other examples. If you go to your Blackboard page, let's open up our ebook. And the first part of 8.1 gives quite a bit of theory about the background, but then the last part, I believe it's example 5, let me double check here. Example 5 gives you kind of a similar problem of what we went through, a different context, which is a good one to work through and make sure you can reproduce the answers in the book using StatCrunch. Your book will go through the illustration and show you how to use z-scores, but going to StatCrunch allows us to skip the step of using z-scores and just use the built-in normal probability calculator. So you want to make sure you're carefully reading Chapter 8, the theory behind the sections. They go through some examples and show you what they mean with samples and how they sort of organize this into a spreadsheet instead of the applet that we were looking at. So just kind of a different way to think about it. So read through these first few examples carefully. They don't have a lot of by hand work. It's more just background and theory that they're describing. I do want to point out they give you the exact same formulas that we talked about, the standard deviation for the sample mean, and then notice they've described this as the mean of the x-bars is equal to the mean of the population, just using your original mu. They go through some different calculations from those examples. You want to make sure you can follow these. You do have to do the standard deviation calculation by hand. StatCrunch doesn't do that for you. You have to be able to put that into the normal curve to calculate your probabilities. So it goes through some more examples here. But what I want to point you to, just really quickly for example 5, is the part that you're skipping. The part that you're skipping using StatCrunch is kind of the part involving z-scores and then using table 2 to calculate those probabilities and doing complements. So really, when you're reading through these solutions, you have to do the standard deviation calculation. It's really in the last step that you're going to diverge. So in particular, I want you to pay attention to example 5. Example 5, you've got several videos. Make sure you're watching the explanation and then the StatCrunch part. Make sure you can reproduce the answers that they get by hand in the book using StatCrunch. All right, guys, that's going to be a wrap for 8.1. Work on these problems. Let me know what questions you have.